Units 9 through 10, Exp Log Booklet 5. Solve exponential and logarithmic equations. Exponents and logarithms are inverses of each other. Means opposites. For the exponent, if we have e to the x, the log form of that would be ln of x. 10 to the x would be log of x. 2 to the x would be log base 2 of x. And then 2 to the x plus 5 power would be log base 2 of x plus 5. If we have the formula b to the y power equals x, b is the base, y is the exponent, and then x would be the argument. These variables, sometimes the x and the y are switched, sometimes instead of a b it's an a, but these positions are always those specific vocabulary. Let's solve this equation. 3 to the 5x plus 2 power equals 3 to the 8x minus 10 power. To get rid of the 3's, we're going to log base 3 each side of the equation. Make sure you put the logs on the left side of each expression. Once you do that, the logs and the 3's cancel out and you're left with a linear equation to solve. Subtract 5x from each side of the equation. Break down the 2 equals 3x minus 10. Add 10 to each side of the equation. 12 equals 3x. Divide each side by 3. 4 equals x. And that's our solution. On the next one we have 2 to the negative k times 2 to the negative k equals 8. Let's use the exponent rule. Adding exponents, our product rule. 2 to the negative k plus negative k equals 8. 2 to the negative 2k equals 8. From there, we want to log base 2 each side of the equation. Again, make sure you write those logs on the left side of the expressions. Definition of log. Those cancel. And so you have negative 2k equals log 2 of 8. You could think of log 2 of 8 as 2 to some power equals 8. That some power is equal to 3. 2 times 2 times 2 is 8. So we can rewrite this again. Negative 2k equals 3. Divide each side by negative 2. K equals negative 3 halves. Ten to the x plus 3 power minus 7 equals 44. Let's add 7 to each side to isolate the exponent part. So we have 10 to the x plus 3 power equals 51. We are going to common log each side to get rid of the 10. A common log has a base of 10. X plus 3 equals log of 51. Subtract the 3 from each side. And then you have x equals log 51 minus 3. Some places will have you put it as an exact answer like this, or you can approximate it in the calculator and round. Let's plug that in. Log of 51 and then minus 3. Negative 1.29 approximately. And then that would be our solution. Find the inverse. F of x equals 2 to the x minus 1 power plus 7. To find the inverse, let's first let f of x equal y. Next, switch the x and y. X equals 2 to the y minus 1 power plus 7. After that, let's solve for the new y. Subtract 7. X minus 7 equals 2 to the y minus 1. We're going to log base 2 each side. You have log 2 of x minus 7 equals y minus 1. And then add 1 to each side. And then you have y equals log base 2 of x minus 7 plus 1. You can't add the negative 7 and the 1. You just leave them like this. The negative 7 is inside the parentheses, inside the logarithm, and the 1 is not. It's on the outside. Our inverse is f inverse of x equals log base 2 of x minus 7 plus 1. If the third term is 4 and the seventh term is 2,500, what is the common ratio? Common ratio is represented by the letter R. Third term is 4, so this is going to be x1, y1, x2, y2. It's similar to finding the slope of 2 points for a linear equation, except for instead of it being a power relationship, it's now exponential. So if we plug these into the formula right here, we get R equals 2,500 divided by 4 raised to the 1 over 7 minus 3 power. We have 625 to the 1 over 4 power. 625 is the same thing as 5 times 125, which you can break down further as 4 5s. So the answer would be 5. Your common ratio is 5. They'll be multiplying each term by 5 to get the next term. If the second term is 4 and the fifth term is 25, what is the common difference? Sometimes it's called D, sometimes it's called M. This is just slope, the regular slope from Algebra 1. Let's label x1, y1, and x2 and y2. So we have x1, y1, x2, y2. The x's is representing the number, the position of the term, and then the y's are representing what that term actually is. We'll plug it into the formula. D equals 25 minus 4 all over 5 minus 2. 21 over 3. That gives you 7. So your common difference is 7. That means each term in the sequence, you add 7 to get the next term. Let's solve this. ln of 3 minus x equals ln of x squared minus 3x. To get rid of the ln's, we will base each side by e. That will get rid of the ln's, and you're left with a quadratic equation. Let's move everything to one side except for 0, so minus 3 plus x. We have 0 equals x squared minus 2x minus 3. We're going to factor this. If factoring wasn't possible, you could use quadratic formula as well. We will find two numbers that multiply to negative 3 and they subtract to negative 2. Negative 3 plus 1 is negative 2, and negative 3 times 1 is negative 3. So these would work. X minus 3 equals 0, or x plus 1 equals 0. So x either equals 3 or x equals negative 1. They could both be real, they could both be extraneous, or it could be one of each. So check for extraneous. We'll plug it back into the original. Instead of x, we're going to plug in 3. We have ln of 0 equals ln of 9 minus 9. Well, this would be okay and all, but if you evaluate ln of 0, you get invalid input, undefined. And so that would make this x equals 3 extraneous. Now let's plug in x equals negative 1. ln of 3 minus negative 1 equals ln of negative 1 squared minus 3 times negative 1. So for that one, we have ln of 4 equals ln of 1 plus 3. Those are the same, and it's not undefined, so that works. So x equals negative 1 is a real solution. Remember, the equations you want to check for extraneous include absolute value, square root equations, and log equations. Whenever you solve those, you want to check for extraneous, because even if you do all the algebraic steps correctly, if you plug the answer back into the original, it still might not be a true statement. Let's solve this equation. Log 4 of x plus 30 plus log 4 of x equals 3. First, we want to condense the logs with the adding logs property. Log base 4 of x plus 30 times x. equals 3. To get rid of the log, we're going to base each side by 4. We have x parentheses x plus 30 equals 4 to the third power. Let's simplify this a bit. Distribute that x. We have x squared plus 30x equals 64. Okay, let's subtract the 64 to the other side. And then let's try to factor this. And of course, you could use quadratic formula instead. Two numbers that multiply to give 64, and they subtract to 30. 2 times 32 would give you 64. And then the 2 would be negative. X plus 32 equals 0, or x minus 2 equals 0. So your answers are either going to be x equals negative 32 or x equals 2. Let's check for extraneous. Let's try x equals negative 32 first. And we'll plug it into the original. So we have log of a negative number. You can't have that. That's undefined. So that automatically makes x equals negative 32 extraneous. Let's check for when x equals 2. Let's plug that into the original equation. Alright, so we have log 4 of 32 plus log 4 of 2. That's log 4 of 32 times 2. Log 4 of 64 equals 3. 4 to the third power is 64, so that works. This one's a real solution. Alright, let's solve this one. Log of x minus 10 minus log of 6 equals 1. We could combine these with the subtracting logs property first. Log of x minus 10 over 6 equals 1. Base each side by 10. That gets rid of the common log. Those are gone. You have x minus 10 over 6 equals 10. You can write 1 under here, cross multiply. $60 equals x minus 10. Add 10 to each side. 70 equals x. We need to check for extraneous. Wherever we see x in the original equation, we're now going to put 70 instead. Log of 60 minus log of 6 equals 1. So same thing as log of 60 divided by 6 equals 1. Log 10 equals 1. That works. So this is a real solution.